Before we start the for loop lesson, please go ahead and grab a sheet of paper and format it like the image below. You may be able to draw some straighter lines than I was able to with this program. For loops are one of the more complicated but very important pieces to understand within programming. This is the beginning of controlling a huge portion of the program through the value of a variable that we create. When we get into reading arrays, for loops will control how the array appears as well as how it is also read from. This is a very important lesson because we are now having the program run something through a variable. So I'm going to show you the for loop first. I'm going to show you an example, and then we're going to work through an example together in this video. So a for loop consists of three parts. I'm going to go ahead and show you a basic for loop. I'm going to type it here. The first part is where the loop begins at. So what value our controlling variable for the loop starts at. The middle part is where it ends. So we're going to make our loop end in 10 times. The third part is how the loop progresses. And then your usual end information that we do. So I can do some drawing in here. I'm going to go ahead and delete that real quick. So, the first part again, which I'm going to draw out to here, this is where the loop begins. So we can honestly begin at any number. That is the first value, though, that our variable, in this case integer I, is going to have. That's the first value. The second one is where the loop ends. So when our I officially is no longer less than 10 in this case, that is where the loop ends. And our third guy is going to be how the loop progresses. So I++ means it is going to increase I after every piece of code in the loop is complete. Because the plus signs coming after the I mean after. If the plus signs were before, it would increase the I at the beginning of the for loop instead of the end. The same thing goes with the two minus signs together. If they're after the I, after each for loop progression. If they're before the I, before the for loop begins running through the for loop. Probably the biggest thing to remember with for loops is that the computer views I as a number. So let's review our for loop structure from the previous slide. The first one, integer I equals 0, that's where our loop starts. For simplicity purposes, I lowered when our loop is going to end when I is no longer less than 5. That's when we're going to end our loop. And our progression will be I will increase by 1 each loop round. For the loop, we're going to be solving for integer x. And real simply, integer x is going to always equal whatever I is plus 35. So for every time the loop runs through, I is going to increase. So in the loop round, what we are tracking is actually the value of I. So the first time it goes through, the value is going to be 0. Which I need to bring it over here a little bit, it looks like. There we go. First time the loop's going to be 0. Second time the loop value is going to be 1. Then 2. Then 3. Then 4. Now, when the loop goes around again and tries to equal 5, the loop will break because at that moment I is no longer less than 5. I is then equal to 5. So you can see if we start at 0 and we set to less than 5, we're going to get 5 progressions through. 1, 2, 3, 4, and 5. If I was equal to 0, but I was less than or equal to 5, we could then have the I equal 5 run through and give us a 6th progression. So an easy way to know how many times the loop is going to run through, you take this value minus this value, subtract them together, and that's how many times the loop will run through. It will run 5 minus 0 equals 5 times. So then we just have to see what our value for x is going to be. So I'm going to draw these in. So the first time it runs through, x is going to be equal to, I'm going to change my color here so it stands out a little bit more. X is going to be equal to what I is, so the loop round is I, 0 plus 35. So x equals 35. And the loop is just going to keep having x progress based off of the value of I. So in the next round, x equals 1 plus 35, meaning that x equals 36. And the next round, x equals 2 plus 35, so x equals 37. Write down the pattern here. And if we needed to get more values, we would just simply have the loop continue to run. Now, this seems pretty simple till we start messing with the values up here. So I'm going to show you one other example of a different value set on how I can jump around, and then I'm going to have you try an example. Here we have another loop where, once again, integer I starts at 0, which is normal for what we're looking at. The loop is going to break when I is no longer less than 9, but this time we're having our I increase by 2. So let's see what happens. Let's do our first run through. Our I right now is equal to 0, and as a result, if my text box will work here, that'd be great. X equals 0 plus 12, so x equals 12. Simple enough there, but what happens for our progression? Because we're no longer increasing I by 1. Now we're increasing I by 2, so for our next loop round, I is actually equal to 2. Because here in the third part of the loop, that's where we control what I is going to be. So now when we come over here, x equals 2 plus 12, so x equals 14. And then our program will follow that same pattern. I equals 4, so x equals 4 plus 14, meaning x equals 18. And we keep going. I equals 6. So x equals 6 plus 12. So I guess I did jump my math there a little bit. Sorry about that. Now x equals 18. Should equal 16 here. And I need to move this up a little bit. So you can see the next one, I equals 8. X equals 8 plus 12. X equals 20. Now, right now I equals 8. Since we've been increasing I by 2, the next time I is going to equal 10. which our loop cannot do because I is no longer less than 9. So this, at this point, breaks our loop right here because I, in its next increment, would surpass our loop's condition. Okay, now it's your turn. Up here above I have another for loop. I return to our original structure where integer I starts at 0, ends when the loop ends when I is no longer less than 7, and it increments by 1 each time. So I want you to take a moment, pause the video. As soon as I say pause the video, I want you to repause the video and solve this out like I did with the tables. In the loop round, solve for I. So here you go, in the loop round, you're going to say, uh-oh, there it goes. You're going to have the value of I. Dang it. And the result, you're going to have what int x equals. So go ahead, pause the video right now, and come back to this in a moment. And here are the results of the entire loop running through. Yes, you can have negative numbers as a result. So when I is 0, I minus 3 equals negative 3. The loop progresses through because I increases by 1 each time, thus increasing the value of x by 1 each time as well, just from how the equation is set up. So when you come in tomorrow, we're going to do another exercise that practices working with these for loops using the letter I and manipulating it within math problems.